All right, let's take a look at a question where we have an identity with a difference. So looking at our formula sheet, we have this subtraction, and we're looking at our A angle and our B angle. So we've got a A minus B. So looking at that identity then, it's going to become cosine of our A value, which in this case is our 45 degrees, times cosine of our B angle, which is 60 degrees, plus sine of our A angle, which is 45 degrees, times sine of our B value, which is 60 degrees. Now, all of these can be evaluated using the unit circle. So cosine 45 degrees is square root of 2 over 2. Cosine 60 degrees is 1 over 2, so that's a multiplication, plus sine of 45 degrees, which is actually square root of 2 over 2, and sine of 60 degrees is square root of 3 over 2. You can evaluate this further. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. And then we have 2 times square root of 3, which is square root of 6. And then 2 times 2 is 4. We should write this as a single fraction, so it becomes square root of 2 plus square root of 6 all over 4.
We have evaluate. So this one's a little different. We haven't done anything with tan, but these identities are on the formula sheet. So again, on the formula sheet, it's going to look at the first value is our A, second one is our B angle. So we have an addition here. So this, again, coming from the formula sheet, is going to say that it's tan angle A, which is pi over 4, plus tan angle B, which is pi over 3 in this case. Now, all of this is over 1 plus, I take that back, 1 minus tan angle A times tan angle B. In this case, angle B is pi over 3. Now, it does say to evaluate. So this is something we talked about before. We know that tan is actually equal to, so in tan theta is actually sine theta over cosine theta. So if you go back to your unit circle, look where pi over 4 and actually do the division. Now, I don't have enough space here to do all of those divisions. Hopefully, you remember from further back what that's equal to. So I know that tan pi over 4 is actually equal to 1. Again, using those divisions, so if you look at pi over 3 and divide sine by cosine, you will hopefully find that it's the square root of 3. If you're having trouble with that, just leave a message and we can put a video to remind you of how to do that. Then looking at the denominator, so tan pi over 4, we already said that was 1. And then tan pi over 3 is going to also be square root of 3 again. Now we do need to simplify this as much as possible. So 1 times square root of 3 is square root of 3. Now, the problem here, though, is we have a radical in the denominator, so we need to rationalize. So I'm going to have to multiply by 1. That's way too big. There we go. 1 plus square root of 3. And when I do to the denominator, I do to the numerator. So if you've forgotten, we're multiplying what's called the conjugate. So the biggest difference between the denominator and our conjugate is the subtraction becomes an addition. I'm really regretting not figuring out how to make this board bigger, but we're going to actually simplify this. So 1 times 1, so using FOIL, is 1. This is a perfect square, so I do know that that middle term is going to be 2 times the square root of 3, so it's just double. And then square root of 3 times square root of 3 is 3. Now in the denominator, this is a difference of squares, so it's going to end up being 1 times 1, and then square root of 3 times square root of 3. So I'm going to get negative 3. Now unfortunately, again, space is at a premium here, so I'm going to go and erase this. 1 minus 3 is actually negative 2. Where that negative goes isn't a big deal. I'm going to actually put that negative sign in front of everything, sort of. We'll put a different color. So some keys here, make sure you're rationalizing. And so we have that conjugate. That's from grade 11. And we have now evaluated. Uh, we're going to leave it an exact value. Yes, I can put it on a calculator, but then all of this was kind of for waste. Oh, we're going to skip that one. I've decided just now. So it says determine the exact value. So cos 165 degrees, if you go and look, it's not on the unit circle. So that should be tell you right away, hey, I have to use an identity. So I have to think about two angles that add up to 165 degrees that I know are on the unit circle. So for me, I know that 45 degrees plus 120 degrees is equal to 165, and both 45 degrees and 120 are both on the unit circle. Once I have that, I can actually use my identity now to figure this out, or at least the exact value of it, which is our goal. So going to the formula sheet then, I'm going to find that it's cos times angle A, and angle A in this case is 45 degrees, times cos angle B, which is 120 degrees, minus sine A, so our A angle, which is 45 degrees, times sine 120 degrees. So now we're getting somewhere. We can actually start evaluating this. So again, from the unit circle, 45 degrees, cosine is equal to square root of 2 over 2. Oh, sorry, it's not working. No. This video may just abruptly end. Oh, maybe not. Then cos 120 degrees is negative 1/2. And then a subtraction. Sine 45 degrees is square root 2 over 2. And all of this, again, is coming from the unit circle. And then sine 120 degrees is square root 3 over 2. Now we're not done. We have to determine the exact value. So we're going to do the multiplication. Hopefully this works at the bottom of the board. Square root of 2 times negative 1 is going to be negative square root of 2. It's not going to work. So I'm going to have to write this over here. So you get negative square root of 2 over 4. And then, now we do have a subtraction between these. Square root of 2 times square root of 3 is square root of 6. And 2 times 2 is 4. So once again, we have a common denominator. So we should actually make this into one term. So we get negative square root of 2 minus square root of 6 all over 4.